In this video, we will discuss about properties of inverse trigonometric functions. So this is the second video about inverse trigonometric functions. If you have not seen the first video, please click on the I button and you can get it there. Now, we have some set of properties. What we do is, in each set, we will prove one property and the other properties can be proved similarly. Now let's take the first set of properties which says sine inverse of 1 by x is equal to cosec inverse x. X is greater than or equal to 1 or x is less than or equal to minus 1. We don't have to worry about the conditions. We have to just concentrate on the result. Now what we do is, we will put cosec inverse x, which is the RHS, as y. Now when you put cosec inverse x as equal to y, x will become cosec y. So cosec inverse in the right side will become cosecant. So x will be equal to cosec y. And what I do is, we will take the reciprocals. As you know, reciprocal of x is 1 by x. But reciprocal of cosecant y is sin y. Sin and cosec are reciprocals of each other. So 1 by x can be written as sin y. And now when you take sine to the left, it will become sine inverse. So sine inverse of 1 by x as equal to y. But what is y? Y is nothing but cosec inverse x. Therefore, we will get it as sine inverse of 1 by x as equal to cosec inverse x. So this is one of the easy proof. Similarly, we can prove the other two by taking, in this we will take secant inverse x as equal to y, and in the third proof we will take cot inverse x as equal to y. So this is first set of results. Now let's move on to the second set of results, which says sine inverse of minus x is equal to minus sine inverse x. Here what we do is, we will take LHS as equal to y, which is sine inverse of minus x, and we will take this as equal to y. And when you move sine inverse to the right side, so minus x will be sine y. And if you take minus to the right, we will get x is equal to minus sine y. And as we know, when you take minus inside the sign, it will become sine of minus phi. We have seen a proof in first PUC, sine of minus x is equal to minus sine x. Similarly, sine of minus phi will be minus sine y. In the next step, we will take sine to the left side. So sine inverse of x will be minus y. And y is sine inverse minus x. So minus phi will be minus sine inverse of minus x, or sine inverse of minus x. What I do is, I will take this to the left side and I will take this term to the right. So sine inverse of minus x will be minus sine inverse x. So we just write this in the opposite order. We will just take minus to the left side. So sine inverse of minus x will be minus sine inverse x. Similarly, we can prove a result on tan inverse and a result on cosec inverse, proceeding like this. Now in the third set of results, we have cos inverse of minus x will be equal to pi minus cos inverse x. What we do here is, we will take cos inverse of minus x as equal to y. So minus x will be cos y, or x will be minus cos y. But we know that when we have cos, and if we take minus inside, it won't be just minus y. This will be cos of pi minus phi. So in the case of cos, secant and cot, we will have this. Therefore, we can write cos inverse x is equal to pi minus phi. We will take this cos to the left side. So it will become cos inverse x, and that will be pi minus phi, or which is pi minus. What is y? Y is cos inverse of minus x. Hence, cos inverse of minus x. If I take this to the left side, and if I take this cos inverse x to the right side, we will get cos inverse of minus x will be equal to pi minus cos inverse x. Similarly, we can prove a result on secant inverse of minus x and cot inverse of minus x. Once you get the first result, we can similarly do the second and third results. Now in the fourth set of results, this is one of the important result. Sin inverse x plus cos inverse x is equal to pi by 2. Now what we do is we will take the first term, which is sine inverse x, as y. Now as you know, if you take sine to the right, x will be sine y. But as we know, sine and cos are related in one thing. What is that? They are related in terms of complementary angles. So sin y can be written as cos of 90 minus y, or pi by 2 minus y. Now if I take cos to the left, I will get cos inverse x is equal to pi by 2 minus y. But what is y? Y is sin inverse x. So it can be written as pi by 2 minus sin inverse x. And when you take sin inverse to the left side, we have already cos inverse here. So sin inverse to the left side, sin inverse x plus cos inverse x is equal to pi by 2. So this is again one of the important results. Similarly, we have two more results. Here we have to take tan inverse x as y. And in this case, we have to take cosec inverse x as y. And we have to proceed similarly as the first result. Now, in the fifth set of results, this is one of the important formula while solving the problems also. Tan inverse x plus tan inverse y can be written as tan inverse of x plus y divided by 1 minus xy. What we do here is we will take the tan inverse x as some angle theta and tan inverse y as some other angle pi. And in that case, what happens? X can be written as tan theta when you take tan to the right side, and y can be written as tan pi. And we have studied a formula about tan in first PUC, which says tan of x plus y or theta plus pi will be tan theta plus tan pi divided by 1 minus tan theta into tan pi. But here tan theta is nothing but x, tan pi is nothing but y. We will replace these values with x and y. So we will get it as x plus y divided by 1 minus xy. Now we will take this tan to the right side. So we will get theta plus pi as equal to tan inverse of this value x plus y divided by 1 minus xy. But what is theta? Theta is nothing but tan inverse x. Pi is nothing but tan inverse y. When you substitute these two values, you will get tan inverse x plus tan inverse y as tan inverse of x plus y divided by 1 minus xy, which is our required result. Second one is same thing, only one change is minus, and you can observe here the sign will be changed. Sign will be reversed as in the first case. This result can be obtained just replacing y by minus y in the above result, that you can do it easily. And the third one, 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. Here also we can replace y by x, we get the result or the answer of this. And for the last part of results, we have this. 2 tan inverse x is equal to sin inverse of 2x by 1 plus x square. What we do is we will take this tan inverse x as y, and then as we know x will be tan y, and we will take the RHS, which is sin inverse 2x by 1 plus x square. But what is x? X is nothing but tan y, so we will substitute. So this will be 2 tan y by 1 plus x square is tan square y. And we have seen this result somewhere. As you are right, this is nothing but sine of 2y. So this is the formula for sine of 2y. Now we have sine inverse of sine x form. As we know, sine inverse of sine x is x. So sine inverse of sine 2y will be 2y. But what is y? Y is tan inverse x. So that will be 2 tan inverse x, which is LHS, and that's the proof. Now we have one more thing, our second proof. 2 tan inverse x is equal to cos inverse of 1 minus x square by 1 plus x square. We have to proceed similar to this. We will take tan inverse x is equal to y, then x is tan y, and we take the RHS. When you substitute the formula here, we get this as cos of 2y, and when you simplify, you get the same thing. Similarly, in the third one, 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. We substitute the same thing. Tan inverse x is equal to y, x is tan y, and if you take the RHS, this will become tan of 2y, and when you simplify, you get the same answer. I hope you can try these two similar to this. In the next video, we will discuss about some important problems on inverse trigonometric functions.